Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform. I'm your teacher Mone Kinyaga. The subject is chemistry. We want us to continue from where we left. In our previous lessons we discussed energy level diagrams, the endothermic energy level diagrams and exothermic energy level diagrams. So ensure that you've understood those energy level diagrams before we move to the next part. In this lesson, we are going to discuss enthalpy notation. The main objective for this lesson is that by the end of this lesson, you should be able to define two terms. The first term is enthalpy, and the second term is enthalpy change. So our subtopic is enthalpy notation. I will start by defining two important terms. The first term is enthalpy. Enthalpy is the energy content of a system. Enthalpy is the energy content of a system. This is abbreviated as H, capital H. So anytime you see H, capital H, then you know that that is the enthalpy. So the energy content of a system, it is abbreviated as H. The second term is enthalpy change. Can you see that enthalpy change, this is the energy change realized when a reaction takes place, or the energy change involved or absorbed so the energy change evolved or absorbed in a chemical change or a reaction. Remember in the previous lessons, we have discussed endothermic and exothermic reactions, where we say that in endothermic reactions, energy is gained from the surrounding, or energy is absorbed from the surrounding. And in exothermic reactions, we said that energy is lost to the surrounding. So the enthalpy change is that energy change realized, or energy change which is evolved or absorbed in that chemical reaction. It is abbreviated as, that is the abbreviation for enthalpy change. So a delta H, it's abbreviation for enthalpy change. So it is not possible to determine the enthalpy of a system, but it is possible to determine the enthalpy change when either energy has been gained or energy has been lost in a chemical reaction. Therefore, this enthalpy change Enthalpy change is given by the enthalpy of products, then you subtract the enthalpy of reactants. So enthalpy change is given by enthalpy of products, you subtract enthalpy of reactants. That is how you are able to get enthalpy change. Then again, you'll realize that in our previous lesson, we said that in endothermic reactions, energy of product is higher than energy of reactants. Energy of reactions, no, in endothermic reactions, energy of product is higher than energy of reactants. And this is what we illustrated using ammonium nitrate, where we say that if you mix ammonium nitrate with water, then you stir. Ammonium nitrate dissolves in water. Then it is dissolved in water with loss of energy. Okay, the temperature was decreasing. So meaning that energy is gained from the surrounding. So if you gain energy from the surrounding, so it now means that the energy of the products will be higher than energy of the reactants. That is in an endothermic reaction. Then in exothermic reactions, energy of products is lower than energy of reactants. Energy of products is lower than energy of reactants. We did this illustration using sodium hydroxide, that when you dissolved sodium hydroxide in water, the temperature, and when you dissolved sodium hydroxide in water and you stirred, then the temperature was rising. There was a rise in temperature, meaning that heat is lost to the surrounding. So when heat is lost to the surrounding, then it now means that the energy of the resultant products, or the energy of the products, will be lower than energy of the reactants because some heat has been lost to the surrounding. Therefore, endothermic reactions will always have a negative sign. Sorry, endothermic reactions will always have a positive sign, meaning that energy is gained. So when energy is gained, then in exothermic reactions, energy is lost. So energy is lost. Therefore, we expect that in endothermic reactions, the enthalpy change is positive. In endothermic reactions, the enthalpy change is positive. Energy is gained in the system. Then in exothermic reactions, the enthalpy change is negative. Enthalpy change is negative in exothermic reactions. Then in endothermic reactions, enthalpy change is positive. Then maybe to show you using our previous illustration using endothermic and exothermic reactions, to show the previous illustrations, then we say that in endothermic reactions we used ammonium nitrate. This is a formula of ammonium nitrate, which is a solid. Then when we dissolved it in water, then we were getting ammonium nitrate solution. Ammonium nitrate solution. Then in the second illustration, then we used sodium hydroxide. So we dissolved it in water, and you got sodium hydroxide solution. So this is an illustration of an endothermic reaction. This is an illustration of an exothermic reaction. Then maybe now to include the enthalpy changes, so when you include the enthalpy changes, then this one will be positive. It will be a positive change. On the enthalpy change is positive. Then this the enthalpy change is positive. This is so the enthalpy change in an endothermic reaction is positive because energy is gained. Then in an exothermic reaction, the enthalpy change is positive. That is the examples we used in endothermic and exothermic reactions. Then those are the enthalpy notation, is how you come about the enthalpy notation. So you just need to know that in exothermic reactions, then energy is lost to the surrounding. Then in endothermic reactions, energy is gained into the system. Therefore, the enthalpy change for an endothermic reaction will be positive. Then the enthalpy change for an exothermic reaction will be negative. Now maybe to include the enthalpy changes, then this one will be the ammonium would dissolve ammonium nitrate in water, then the enthalpy change will be negative 25.2 kilojoules per mole. Then for the sodium hydroxide, when you dissolve it in water, then the enthalpy change will be negative 43. So this is positive because energy is gained from the surrounding. This is negative because energy is lost to the surrounding. Then maybe to explain why we are getting 25.2 and 43, this is the energy change which will be realized when you dissolve 1 mole of sodium, not sodium, but ammonium nitrate in water. So when you dissolve 1 mole of ammonium nitrate in water, then you'll get the enthalpy change is positive 25.2. The energy which has been gained from the surrounding is 25.2 kilojoules per mole. Then when you dissolve 1 mole sodium hydroxide in water, you will get 43 kilojoules has been lost to the surrounding. Then for 1 mole of sodium hydroxide, for the sodium hydroxide, the 1 mole will be the mass of sodium, the mass of oxygen, and the mass of hydrogen combined. So the mass of sodium is 23. That is the mass of sodium. Then for the oxygen, the mass is 16. And for the hydrogen, the mass is 1. So when you add them together, you're getting 40 grams. So negative 43 kilojoules per mole is now the enthalpy change which will be realized when you dissolve 40 grams of sodium hydroxide in sufficient amount of water. Then for the ammonium nitrate, the mass of nitrogen is 14. This nitrogen, and there are 2 atoms of nitrogen elements. So this nitrogen and this one. So 14 times 2. Then the next element is hydrogen. Hydrogen has a mass of 1, and there are 4 atoms of hydrogen. So you multiply by 4. Then the next element is oxygen. Oxygen has a mass of 16, and there are 3 atoms of oxygen element. So you multiply by 3. So this is 28 plus 4 plus 48, which is going to give you 80 grams. So positive 25.2 kilojoules per mole is the enthalpy change which will be realized when you dissolve 80 grams of ammonium nitrate in sufficient amount of water. Those are very important things to understand. So 1 mole, this is the energy change realized when you dissolve 1 mole of a salt or a chemical in sufficient amount of water. Therefore, these are what we are calling the enthalpy notation. Enthalpy notation. So ensure that you understand that. In an enthalpy notation, then there is a balanced chemical equation and the enthalpy change for that reaction. So we must write a balanced chemical equation and the enthalpy change, which we have included here in our case. Therefore, make sure that you've understood. In this lesson, you've learned that make sure you can be able to define what enthalpy is, what enthalpy change is. Then you can now be able to denote or to be able to include these enthalpy changes in a reaction. I will leave you with an assignment, and the assignment is define the following terms. first term is enthalpy, and the second term is enthalpy change. To find the following terms, we have the first term is enthalpy, then the second term is enthalpy change. Ensure that you've done that assignment before we meet in the next lesson. Thank you for being attentive.